Uh, Welcome back to another video. Now, in this video, we're going to talk about density. Now, usually, when I'm teaching in a class, and I usually ask people a question like this: which one is heavier, a piece of metal or a piece of wood? And usually, uh, people straight away say the metal is heavier. But then I tell them, if I give you a small piece of metal and a large block of wood, which one is heavier? Then they have no answer to that. Because if you want to compare the two, the metal and the wood, then we must take the same size piece of metal and the same size piece of wood. In other words, we have to take the same volume of each material if we are to compare their heaviness or how heavy they are. Now, density is like a heaviness of a substance. And we define this as mass divided by the volume. Okay, how much mass the substance has, divide by the volume, and this is the formula for density. And we measure the mass in kilograms, and the volume is measured in cubic meters. This is the SI unit which we're going to use. Now, if you measure the mass in grams, then the volume is in cubic centimeters. We can also have the density in grams per cubic centimeter. But mainly it's the SI unit that we are going to use, which is kilograms per cubic meter. Now, looking at certain substances, like if you take water, has a density of 1000 kilograms per cubic meter. Now, what does that mean? If we take 1 cubic meter of water, it will weigh 1 kilogram. Now, 1 cubic, just to give you an idea, if you take a tank which is 1 meter by 1 meter by 1 meter high, okay, 1 meter long, 1 meter wide, 1 meter high, is full of water, it will weigh 1000 kilogram. If you have the same tank full of steel, it will be 8000 kilograms or 8 grams per cubic centimeter. Gold is fairly heavy, okay, which is 19,000 or 19 grams per cubic centimeter, which is 19 times heavier than water. Now, the densest material we know, the element that we know, is osmium, whose density is a little more than 22 grams per cubic centimeter, or 2,200 kilograms per cubic meter. Right, this is in kilograms per cubic meter. Now, air has a density of 1.3 kilograms per cubic meter. Now, we can write the formula. Density is D equals m over V. I can use that in a formula triangle. If you want to find the density, you cover D is mass divided by the volume. If you want to find the mass, it's volume times density. If you want to find the volume, it's mass divided by the density. Now, we'll do an example. It says mass of air is contained in this room, in a room measuring 6 by 5 by 3. Now, we think of air as something very, very light. No, we say something is as light as air. Now, see how much room, how much weight of air is contained in this room. Okay. Now, to work this out, we know the density of air is 1.3 kilograms per cubic meter. Now, volume of air is equal to, the room is a cuboid, and it measures 6 meters by 5 meters by 3 meters. So it's length times width times height, which is 6 times 5 times 3, which is 90. 6 times 5 is 30. 30 times 3 is 90 cubic meter. So it's 90 cubic meter of air in the room, and its density is 1.3 kilograms per cubic meter. This is the volume. This is volume. This is the density. To find the mass, okay, we use the formula M. Mass will be volume times density. Mass equals volume times density. The volume is 90 and the density is 1.3. Now, if we work that out, 112 kilogram. Now, we find that the mass of the air in the room, in this room, which is not a very big room, it's only 6 meters by 5 meters by 3 meters, and the volume of air contained in this room is 112 kilogram. How does that compare with your weight, your mass? Well, I weigh about 65 kilo, so it's nearly twice my weight. So air is not that light. Now, we want to know how to measure density. So we want to write down experiments to measure the density. Measuring density. Okay, if you do an experiment to find the density of, say, some liquid. Now, all you need to do is, to find the density, we need the mass, we need the volume. Okay. Now, the mass we can find by putting it on a scale, and the volume you can for a liquid, you just put it in a measuring cylinder and then you read off the volume in cubic centimeter. If you want to find the density of an irregular solid, okay, finding the liquid is very, very easy. Irregular solid, measuring density of irregular solid. Like, for example, a piece of stone of irregular solid. So what we do is use the scale right. An irregular solid like a piece of stone which doesn't have any regular shape. Now, to find the volume, what we can do is we can do two things. You can put some water in a measuring cylinder and suppose the level of water is there. Okay, now remember this is graduated in centimeter cubed. Now, what you do is, then you take the irregular solid, like a piece of stone, and you lower it. Okay, this is an irregular solid. You attach it to a string. Okay, so what you do is you slowly lower this into the cylinder. So what's going to happen to the water? The level of water is going to go up, and it will go up by an amount. So here you measure the volume V1, here we measure the volume V2. So when we lower it, the level of water is going to go up to V2. You measure this in cubic centimeters. Suppose the first reading was 10 centimeter cube, or say 50 centimeter cube. Okay, now when we lower the stone, the volume has gone up to, let's do it in a different color, 50 cm cubed, and this volume has gone up to 70 centimeter cubed. Okay, so the volume of stone will be equal to the amount of water that has been displaced. Okay, so volume of solid equals V2 minus V1, which is 70 minus 50, which is 20 centimeter cube. Now, this is one way of doing it. If the object is large and it doesn't fit into a cylinder, we can use a Eureka can, which is a can which looks something like this, and it's designed, which has a spout like this, and this is filled up with water. No, this is filled up with water. Right up to the top. Now, what happens when we lower the piece of stone in there? When we put the piece of stone in there, or piece of solid, irregular solid, then this is going to displace the water equal to the volume of the stone. Okay, and that water is going to come out. Okay, it's going to spill out into the beaker. Now this is called Eureka can. Okay, and the volume of this will be equal to the volume of the stone or the irregular solid, and we can find the volume that way. So then we can work out density equals mass divided by volume. Now the mass, we remember we have found by using a scale, measuring scale, and then volume you can find like this, and you can calculate density. We use this formula to calculate the density. And this is how we can find the density of any irregular solid.